Kia ora and welcome to video 18 in the series Delightful Differentiation. Today's problem is a fairly quirky problem. Let's have a look at it. We have a parabola and we have a circle, and the parabola and the circle are tangent at 2 points. We're given one of those points, 0, 22, and we need to find the other and also the value of k, the scale factor of the parabola. So the picture there is just to use as a guide. It doesn't relate directly to this question, so don't be thrown off by that. In fact, for this problem, k is negative, and therefore the parabola is upside down. Good luck with the question, and we will see you after the intro music for the solution. Okay, this problem is quite hard to visualize because of the numbers that are involved. So the parabola y equals kx squared plus 22x plus 22 has a y-intercept of 22. It has a scale factor that we're trying to work out. The picture there is not exactly the same, but it shows that the parabola is going to have to be quite steep to be tangent to both sides of the circle. We're told there exists one circle which has its centre on the x-axis and is tangent to the parabola at exactly 2 points. Now that tells us the general form of the circle. If its centre is on the x-axis, we don't know exactly where the centre is, but we know that it's got a y value of 0. Our circle will be something like x minus a all squared plus y squared equals r squared. I put this question into our 2022 scholarship mock exam that we had at our school, as is the sort of common pattern with exams and sometimes Olympiad competitions. The year 22 featured in this problem a couple of times. If one of the points has the coordinates of 0, 22, so we know that the circle is tangent to the parabola at that point, find the coordinates of the other point. So we're going to have to use some symmetry here. I think the best way to do it is just to show you the answer straight away so you can visualize it, and then we'll go about the maths. So let's just have a quick look at Desmos. I've already made the graph. We find that the k value is negative 1 over 44, and we can see there, if we zoom in, the tangent at 0, 22, and then on the other side of the circle, tangent again. It's kind of hard to zoom onto that, but it's got to be the same y value, given that the circle hasn't moved up or down. It's got a centre sitting on the x-axis, and the parabola must have a turning point that's halfway in between. If you zoom out, you can find that. So there's the turning point of the parabola at x equals 484. Okay, so the symmetry is going to help us to solve this problem, but like I said from the outset, it's quite a hard diagram to visualize. Alrighty, so what do we do with the maths? The first thing is, if they share a common tangent, the parabola and the circle, then their derivatives must be the same at 0, 22, because we're told that that is a point where these two things are tangent. So differentiating first, if we take our circle equation, the parabola first, 22x plus 22, and we differentiate that, we get 2kx plus 22. Then we take our circle equation. I won't bother rearranging this, I'll just use implicit differentiation. Diff the first term, 2 lots of x minus a. Diff the second term with respect to x, so 2y times dy dx, and then the term r squared is a constant, so it diffs to 0. We can rearrange this one. Dy dx equals a minus x over y. The 2's cancel. Alrighty, so now if we equate those expressions, the gradients are the same at the point x equals 0. At 0, 22, or x equals 0, the gradients are equal. Okay, so subbing x equals 0 into both expressions, we get 22 equals a over 22, or a is equal to 22 squared, 484. So that's telling us where the centre of the circle lies, 484 across, and I showed you that with the Desmos graph. Let's quickly go back to that. The centre of the circle is 484 across. It's also where the maximum of the parabola is, because of the symmetry of this problem. Okay, the maximum of the parabola must be directly above the centre of the circle, which you need to understand. So therefore, we can take the gradient function of the parabola and make it equal to 0. Gradient of parabola equals 0 at x equals 484. Therefore, 0 equals 2k multiplied by 484 plus 22. So I'm using the equation for the gradient function of the parabola, and that information of x is equal to 484, gradient equals 0. And if I solve this expression, I can get k is equal to minus 1 over 44. And then lastly, I need the symmetry, is the symmetry argument. If I know that one of the points is 0, 22, is a point where they are tangent. Okay, well, and you think of the centre of the circle is at 484, then we need to go another 484 to get the other tangent point. Therefore, 968, 22 is the other point by symmetry. So, like I said, quite a tricky problem to visualize from the outset, but we definitely needed a diagram to sort of think about the symmetry that was involved. Other than that, we're just subbing in points into gradient functions, which isn't too nasty. The calculus is pretty straightforward. And we can always check our answer. So if we got a silly value for k, or we got an a value that just didn't make sense, when we graph it, we would know that they're not tangent. And so therefore we would try to find the error in our working. Catch you next video.